We should be ready to go. Let me just see real quick. Looks like we still got a few people trickling in here. I'll just wait another minute. Okay, cool. Go ahead and drop an emoji in the chat if you haven't done so already. And we're going to get started. Okay, cool. So I wanted to pick back up on control flow. I wanted to start off with control flow. I do want to do the overview again today. It kind of got interrupted yesterday, so I think it'll be good to go over that again. So basically, I'll just do this overview again. The things we're going to cover in this course are designed to get you up and running. They're not designed to necessarily give you like an exhaustive understanding of all the features in Python, but they are the things that we teach and the way that we are kind of oriented around teaching is meant to give you all the tools that you need so that you can go and learn any other feature of Python, any other library. So it's meant to be the foundation that you can build off of. And at the core of that foundation was just understanding basically your types, your abstractions, control flow, and iteration. So the types that we've talked about so far, we've talked about int and float and bool. I'll put bool on its own line. Even though technically bool is a numeric type, but still sort of think about it differently. We've also talked a little bit about strings as well. And there's I've mentioned none. I've mentioned the none type. We kind of brought that up, and I'll get a little more into that when we get into functions. And today, if we have time, we're going to talk about lists as well. I'll leave those off for now. Abstractions. The two types of abstractions that we're going to cover are variables. There's not much to variables. They're just simple. It's just you have a piece of data, and then you have a variable that names that piece of data. So it's just a way of assigning a name that you choose, that you get to write as to a piece of data. And then functions, which is going to be probably the meat of what we're going to discuss today. I did mention this yesterday. There's another one, which is classes. So a class is sort of a way of grouping sort of stateful points like variables and logical processes like functions, sort of grouping those together. That's one of the things that classes do, and classes do a few other things. We can actually make our own custom data types with classes as well. But we're only going to touch on that later, and we may actually skip that depending on the amount of time that we have in class. Then control flow. So control flow we talked about yesterday. We're going to talk about more right now. Control flow involves there are three keywords that we want to know: if, elif, and else. So these are the three control flow keywords. We also have things that sort of relate back to the Boolean type, that are sort of relevant to control flows, to control flow as a topic. So basically the anatomy of control flow statement is we have our if or elif, whatever. We have our if, and then our condition. So I'll just say some condition. And a condition is any expression. Well, I'll kind of do a little quiz on this. Who remembers how I defined a condition? Go ahead and put it in Slack. You don't have to be exact, you can paraphrase. I'll let you all put it in your own words. Cool. So we've got an expression that evaluates to true or false. Yeah, exactly. So condition is any expression that evaluates to true or false, right? So we talked about a number of things relating to the Boolean data type, right? So this kind of brings me back to how we would work through understanding each of these types. One of the things I do is go around and kind of write down all the operators that either take that type as an input, operators, functions, methods that would take that type as an input or give that type as an output, right? So for example, the less than operator, well, it actually takes in an int or a float as an input, but it gives back a Boolean, right? So less than, greater than, less than equal, greater than, equal, equal, not equal. There we go. Missed one there. I should take these commas out, actually. That's kind of confusing. Okay, so these are our Boolean operators. Some other operators that give back Booleans are not, and or. And we talked about these. And these also take in Booleans as their operands, right? So not takes a Boolean after it, and if it's a true, it turns it into a false. If it's false, it turns it into a true. And an or also take in Booleans. They each take in two, one on the left and one on the right. Cool. Right, and understanding this is pretty key to understanding how to write control flow statements, because we have to know how to write conditions, and a condition is any expression, anything that expresses a Boolean value, right? So this is our Boolean, it's either true or false, and here's a bunch of operators that will sort of be at the heart of giving us a true or false answer. Not all conditions will involve these, but it seems a little reductive to say most will, but honestly, I think most of the time you're writing a condition, you're going to end up involving a couple of these, or one or more of those. But by no means does a condition require the use of these. There's a lot of other ways that we can get sort of true and false expressions, but we'll get into those weeds later. Cool. So We have our conditional keyword, then we check some condition. And then if that condition is true, we have a consequent, and then that's it. Is not considered a negation of a Boolean. You could think about it that way. Yeah, you could think about the expression true as expressing the value true, and the expression false as expressing the value false. And you could also think about the expression not true as expressing the value false, and the expression not false as expressing the value true, right? So you could think about it as a negation of a Boolean. Yeah. Cool. So that's our types, our abstractions, control flow. Iteration is a way of repeating processes. So the primary means of iterating that we use are loops, and we have two styles of loops. We have for loops and while loops. But we're going to kind of get into these a different day. So we might actually get into them in lists a little bit, but that's if we have time. Okay, cool. So this is really all there is at the core of any programming language. When I go learn a new language, I try to learn these things to start with, and then from there, I can basically learn any library in the language. There might be some. If I was learning Java, I'd have to learn classes. I wouldn't have a choice, right? So there might be some other details in a given language, but basically, I know for sure I want to know how to do these things, or how to address these issues. What types are available to me, and how do I work with them? How do I write control flow logic? Some languages don't necessarily have if, else. There's a language that I like called Haskell that has no looping structures whatsoever, and you have to use recursion. But you still do iterative processes. You just do them differently without the aid of loops. So any language that you go and learn it's just these four things at the core, and then from there, you can use this to learn everything else about the language. Okay, cool. So let's cover control flow again, and yeah, I'll just jump right into it. So let's get some values. A equals 4, B equals 5. And we'll say if A is less than B. So this is our condition. Then we put in a colon, and the colon just tells Python, excuse me, gosh. The colon just tells Python that the condition is over and that we're going to go into the consequent, right? And the consequent is just obviously it's the consequence of whether it's the thing that we do if that condition is true. So if it's true that A is less than B, which in this case it is, our consequent will just print just A is less than B. Okay. So, and then we'll print we'll just do that. Okay, so we write our condition, we type a colon to say that the condition, we're done writing the condition, and then we go to the next line and we tab in 4 spaces. You can hit the tab key if you're in any modern environment, it'll put in 4 spaces for you. It won't actually put in a tab character. So the reason we want to tab that in is Python has to know what code that we're designating as the consequent to this function. We can have multiple lines of code in here, right? It can just be any arbitrary number of lines of code in here. It can be complicated or simple or whatever. So we can have that code in there, and we just need to tell Python which code should be executed as the consequent to this condition, and which code shouldn't be, right? So the way that Python knows is all the code that's tabbed in is the code that's going to be executed if that condition is true. If that condition is false and we have special code that we want to run only if that condition is false, we can say else. Else A, let's just print, we'll do this. Print A is not less than B. Real quick here. Here we go. Okay, so A is less than B. So notice it did not print A is not less than B. And then if I make A, let's see this, A is greater than B. So if I make A 6, A is 6, B is 5. So now it says A is greater than B, right? But what if I do this? What if I say, what if I make them equal? Well, it's going to tell me that A is greater than B, even though 5 is not greater or less than 5. It's equal to 5, right? So this code is not quite giving me an accurate statement. So what I want to do is, if I check A is less than B, and it's not less than B, it could be either equal to B or greater than B. So before I print it's greater than, I'll check if it's equal. So the way I would do that is I would say elif, ELIF, and elif, as you most likely can deduce, is a combination of else and if. The else part basically just says, okay, so given that the previous condition, this condition that I have highlighted, given that that condition was false, then check this condition, right? So the if part means check this condition. So else says, so that condition, the prior condition was false. If says, check this next condition, so elif. So elif A equals to B, we can do that. And just to be clear here, I always do this thing where I kind of line things up. And it's strictly an aesthetic thing. It's a habit that I have from just kind of making my code pretty. You don't have to do that. I know that might look funny to some people, so you can leave your if statement like that. But I like to do it that way. So, yeah. So if A is equal to B, I just want to print A is equal to B. Okay, so I'll check if A is less than B. If that's true, I run print A is less than B. If it's false, then I go on and I check this next condition. And it says, so if A is less than B is false, then I check elif A is equal to B. If it's true, then I print A is equal to B. If it's false, then this else just runs, doesn't have a condition to check. To be clear, it's not that it doesn't have one because I didn't want to give it one. It's that an else necessarily cannot take a condition after it. So I can't have like else A greater than B, right? Like I'll run it and I'll get a syntax error, right? Because I can't have a condition after else. Python looks at that and it's like, wait, what's going on? So else print A is greater than B. So if I run this, it says A is equal to B, etc. Okay, cool. So some rules about the ordering here. Some problems want us to use. Okay, how do I put this? Some problems are best solved with just a single if, right? All we need to do is just put in a single condition. The reason that I'm mentioning this is that I often notice people make a mistake where they will try to they'll try to write all their ifs with an else at the end. And I definitely get that, and I remember doing it myself when I was first learning. I think it's because it feels explicit and it feels complete, right? Like you can check this condition and you say, okay, this is what I'm going to do if it's true. And then it feels like a best practice to say, oh, well, if that's what I'm going to do when it's true, I should also have, just to be safe, I should also have something that I'm going to do explicitly if it's false. There are coding paradigms that are oriented around this idea. I would say that those are a little more advanced. Python doesn't enforce that at all. And kind of those thinking patterns are kind of involved with other types of coding that we're not going to cover here. So it's definitely valid to have certain problems, certain solutions where you just check a single condition and that's all that problem demands, right? Sometimes you'll have an if and an elif and no else. Sometimes you'll have an if and an else and no elif. Sometimes you might have an if, elif, and then a whole bunch of elifs in the middle. If I had one of these be an if like this, I would have you note that essentially what's happening here is I have one chain of conditions that's checked, and then a different chain of conditions that's checked independently. And I wanted to bring it around to this point here. So, oops. Every time we write an if, you can think about it as sort of initializing a chain of conditions. Now that chain can have one or more links, right? So one link in the chain would just be an if. Two would be an if or and elif, or if and else. If we have an else, the chain ends. If we have an elif, we can continue the chain with as many elifs in between. And the reason that I think about it like that, the reason I think about the conditions being chained together, is that the each if, just if, not, and I mean if, not elif. Each if is checked, but if I have a chain of conditions, the first condition that's true, the consequent is executed, and then all the conditions chained after it aren't even checked by the interpreter, right? So every time I have an if, I can basically be sure that given that if is in a scope that's being run, it will be checked by the compiler. So you'll kind of get used to that as it goes. We got a question here. Pylance is compiling or complaining in my VS Code. I'm not sure what Pylance is. I get my experience with VS Code is that it loves to complain about kind of everything. So anytime it pops up anything, I just close it out. I've never had an issue doing that. Yeah. Cool. Okay. So yeah, I know that there's a bit going on here. I think I'll kind of leave that explanation kind of to percolate for now. Like each of these on their own is fairly simple, but I think kind of getting used to like how they all fit together can feel more complicated. But basically, if you just remember a few simple rules, you can't start with an elif or an else. You have to start with an if. And if you want your elif, your next condition, to be an alternate to the previous one, it has to be an elif, not an if, right? So if you don't want it to be an alternate, if you want it to be checked independently, you can start another if. Okay. Yeah, that'll do. Cool. Let's get into functions. And if anybody has any questions about this, feel free to pop them in there. Okay, so let's start by talking about what a function is. So I know Tovio gave you this example in the beginning. They wrote a factorial function, so we'll say def factorial in, and we'll say prod equals 1 for I in range. We need to do, oh gosh, I keep hitting that page up. Do 2 to n plus 1. And we'll say prod equals, times equals I, and return prod, right? So we're going to get into all the nitty-gritty details of this, and in a couple classes, all of the elements of this will have gone over everything. Cool. So one thing that I want to make clear for now is, before we get into anything, a function is useful for being able to write logic once and utilize it as many times as we need, right? So this is a factorial algorithm, but what I don't want to do is have to, write this whole thing out every time I want to use, I want to calculate the factorial of something. And then the thing that I'm calculating the factorial of would go here. So if I wanted to know the factorial of 5, I'd have to remember to put the 5 right there and then actually add 1 to it. So I want the factorial of 5, but I actually have to put in 6, So it would be kind of a pain to have to kind of write this out. Even though that's not that many lines of code, it's a lot easier to just stick it in a function and then just hand the function some inputs and be done with it. So that's what it is. That's its purpose. We can write it once and then use it as many times as we want. So if I want to know the factorial of 5, we can do that. That's 120. So with this, all I got to remember is the function name. And then, so I can say factorial of, and then just hand it a number and it'll calculate and return the factorial. Cool. So one thing to note here, and this is very important, functions have what I'm going to call phases. We're going to call them 2 phases, right? We're going to say they have 2 phases. So one phase is the definition phase and the other phase is the invocation phase. So in the definition phase, this is where we define what the algorithm is. This is where we define the process, how that process works, how that algorithm works. And in the invocation phase, that's where we actually invoke the function. That's where we tell it to run, right? So if I write a function but I don't invoke it, what's going to happen? If I run my code, what's going to happen? makes you feel like a wizard. Yeah, that's honestly partly why I like to use the word invoke for this. Usually, it's most often called calling a function, although I think that's kind of a it can be kind of a confusing term. Um, and everybody knows what you mean if you say invoking a function. So, and it makes you feel like a freaking wizard. So that's what's great about it. All right, let's see. No, that's fine. It'll return 1. That's interesting. Huh. It will load into memory. Nothing happens. Nothing will print. Nothing because I haven't assigned a value to n. Yeah. So there's a lot of good answers here. Yeah. So basically, somebody's saying it'll load this function into memory, which since we're not invoking, I mean it'll scan it. I'm not sure it actually will even load it into memory. It'll look at it, but it'll look to see if it's invoked anywhere. And since it won't find it invoked, I think it actually won't. But I might be wrong on that. But yeah, it'll register that. Oh, okay. Well, there's a function called factorial, and if I see a invocation for factorial, come run this code. So, but basically nothing's going to happen because we didn't tell it to do anything. So this is not a call to action for the interpreter. It doesn't actually ask the interpreter to do anything. It just says, if I did ask you to do this, this is what you do, right? So in order to um, in order to invoke it, we have to name it. We'll say factorial, and then hand it the thing. We want the factorial up like this. So to the point about wizards and wizardry, sometimes I explain this as you can think about the definition as the spell in the spell book, and then you can think about the invocation as casting the spell, right? So this is the spell, and then we have to cast the spell, right? So to read the incantation, as it were. Okay, so now I run my code, and still nothing happens. So see, I'm not getting any output. So who wants to tell me what's going on here, if anything, and why I'm not seeing anything? Okay. So when he's asking what the question is, so now I defined the function and I invoked it. I'm running my code, but nothing's happening. So why is nothing happening? Okay, cool. So we've got print, no print. Yep. Missing print. You are only calling the function. You haven't printed the result to the console, right? So it is running this code, right? It is executing that factorial function. It's calculating the 120 that I asked it to calculate. But what it's not doing is displaying that because I didn't ask it to display it. So what I like to do is print the invocation like this. Cool. So let's kind of get away from this because factorial has some things that we haven't covered yet, but we will cover soon. So let's just write, let's do something like, yeah, let's do def subtract. This will be a really simple function. So if I want to define a function, obviously I need to start the definition. I need to tell Python that I'm defining a function. So I use the def keyword, just def, just like that, and then a space. So I have to have the space in there, a space, and then whatever name I want to give to my function. And this is one of those places, like a variable name. You could just give it any valid name, and it follows the same constraints as naming any other variable in Python. You can't name it a keyword, and Python will allow you to name it the name of a built-in function. Again, I wish it wouldn't allow you to do that, but it totally will allow you to do it. So you just have to remember not to do that, right? So we wouldn't want to say print. So we'll say def subtract. And if you look up here, when I invoked my factorial function, I had the chance to give it a number, right? I have the ability to give it an input, right? So when we are defining a function, what's happening? Oh, sorry, the light is getting a little funky here. Oh, sorry, I meant to turn on this overhead light so that doesn't happen. 1 second, sorry, give me 1 second. Okay, cool. That's better. Okay, so I'm defining my subtract function here. So when I want to say what the inputs are to this subtract function, I'll type parentheses, just a set of parentheses like this, and then in here I get to. It's like I'm creating variables without values, basically. So I'm creating. You can think about it like they're like names of variables, but they don't have values yet, right? And it's important to understand that at this stage during definition, they don't have values. Just the name part. The name portion of a variable is sometimes called an identifier. So it's just the identifier, but not the actual value. So in this case, I'm just going to call it A and B. And if I want to create, obviously, if I want to create multiple inputs, I'll say the name of the first one that I want to use, and then a comma, and then the name of the second one. The space is optional, but it's conventional to put the space there. So this is my function head. This is the head of the function. And then like a control flow statement, we put a colon at the end. And then go on to the next line. And then tab in by 4 spaces. So if I just hit enter, and in most modern environments, it'll just put me on the next line 4 spaces deep. So it knows to indent for me. Cool. And then from here, what I want to say, I want to calculate A minus B like this. So this is the difference. I'll just call it diff equals A minus B. And now I want to tell this function what its result should be, right? So this will calculate the difference. It'll if I invoke this function, it will run this code and it will calculate A minus B. But I actually want that information. I want that to come out of the function. So once this is finished running the code inside of it, I want whatever the result of A minus B is back. Okay? And the way I do that let's do 5 minus 2. The way I do that is I'll say return diff, like that. And I'm just making this variable here. Usually I wouldn't do that, though. Usually I would just do something like that, right? I want to be clear here. If you just need to do some simple subtraction operation, you don't need to go about making a whole function for it. I'm just using this really simple operation just to have some excuse to write all the parts of a function and kind of get everything plugged in together. I wouldn't want you to take away that you know, like every time you have to do a subtraction that you need to make a whole function for it. This is just solely for the purpose of giving an example. Okay, cool. So what this is saying is I'm defining some function called subtract, and I have the parentheses that define the parameters, which are the names for the inputs into the function that the function uses internally in the definition. The colon tells me that the function head is over, and then we go into the function body on the next line, tabbed in one level by 4 spaces. And then for this, I'm just going to do return a minus b. And the return, so notice return is red, like def. We've seen a few other red words like this. This tells me that it's a keyword. So this is one of those built-in words that's built into the language. This is not a function, but what it does, its purpose is to say that whatever is after the return is the thing that's going to be the result of this function, which means wherever I see this function call, and I want you to train your brain to do this, whenever you see a function call, try to see through it into what it returns. I always feel a little silly saying that. I feel like Yoda or something, like you must see through the function into its true nature or something, you know. But it does really help to like train your brain. Every time you see a function call, try to see it as the thing that it returns, right? That doesn't necessarily mean you have to like run the process with full accuracy in your head. Really what that means is like be able to see the type of its return and be able to, you know, have a sense of what that type represents. In this case, this is going to return a number, either an integer or a float. In this case, it'll return an integer because both of the inputs are integers, and it will be the difference of the inputs, right? It'll be the result of subtracting the first input from the second input. So when I look at this, I see, okay, so this is going to, this right here, subtract 5 and 2, is going to evaluate to 3. So this right here is the expression 3, right? This is the number 3. It doesn't look like the number 3, but it is the number 3, right? Here, let's print it out, right? So I'm printing it out and I see 3, right? So that's something that's important. When we invoke it, we see the invocation as the thing being returned. So this is why I was talking about earlier. I was talking about IPO, which is input, process, output. Yeah, so the input for this is, we'll just do, the input is any two numbers. Right, so we can have any two numbers, either an int or a float. The process is sort of, you know, that's what we have to figure out in solving the problem and writing the function. In this case, subtract the second from the first. and the output is the difference. So this is going to be a number, int, or float. The difference between the first and second input. Cool. So this is, like this process, this IPO process, we can apply this to functions that we're learning that are already built, that are already built into Python or that are coming from another library or from somebody else's code. And we can apply this to functions that we're writing as well. And it's okay to omit, one of these if it doesn't seem relevant. In this case, process is relevant because we're the ones writing the function, so we better be able to like build the process. Okay, got a couple questions. You must see the return behind the function neo. Yes, exactly. Where it says subtract, does it have to say subtract, or can it say anything there? Okay, so are you so I've got subtract here and here. Are you talking about one or the other or both? I suspect you're talking about both. Both. Okay. This could be called poodle faces. I highly recommend that you don't name a function poodle faces unless it's like a poodle face recognizer or something like that. But we get to name this whatever you want. Yeah, you're welcome. That's a good question, by the way. Yeah, so this is a good thing. This actually brings me to a good point that I can make here. It's kind of good to keep track of which things, which parts of the code have to be what you see, and which parts you get to name whatever you want, right? So in this, def and return have to be what they are, right? The name of the function is totally up to us. The name of the parameters is totally up to us. The parentheses and the colon are not optional. It's not common to write a function that doesn't take any inputs. It's valid Python. It's legal. So Python will let you do this. And there are times when you do it. It's not that common though. Most of the utility of a function is that it takes in some inputs and it gives some output or returns some value. So we have agency to name the function and the parameters to the function whatever we want. And then we could create other variables, like I had difference. I'm not confident that I spelled difference correctly, but you know what? I know Python, so whatever. We'll do that. So any variable inside the function. So I can create variables inside the function. I can all of the code that we've covered. We've covered some numeric operators and some Boolean operations. We've talked about strings just a little tiny bit, and we've talked about control flow. So all of that can go inside of a function. You can actually you can define a function within another function. And there are paradigms that do that will utilize that pattern, but we're not going to do that at all in here. So don't worry about like defining functions with function definitions within them, right? You will define functions with other function invocations inside of them, right? So Maybe we'll get to some of that. So a couple points I want to make here. During definition, well, I've mentioned this a few times, but let's get extra clear on this. What's the proper name for the inputs here? So during definition, what is A and B called? Cool. So yeah, so the proper name is a parameter. Initially, I did refer to these as variables. So my bad if that was misleading. You can think about these like the name portion of a variable, the identifier portion of a variable, and there is a strong similarity between a parameter and a variable in that a variable is an identifier that has some piece of data assigned to it. And basically the same thing can be said about a parameter. It's just sort of how they get there, the context in which they acquire their value, right? So a variable, we do it on the same line when we just say, this name this name gets this data, right? Whereas a parameter, we say this function has these parameters by these names, but we don't give them information yet. We don't give them values yet. When we invoke the function, that's when we give them the values. So during definition, we call these parameters. If you call them variables, I'll know what you mean, but I will have to correct you because they are technically called parameters. Now, but you can think about them as very similar things, right? When we invoke the function, we say we pass arguments. So we talk about giving the inputs to a function as passing arguments, right? So I would say I'm passing 5 and 2 to the subtract function. You can think about pass as like handing over, like passing, from me to the function. I guess that's the analogy there. So, but during invocation, when we invoke it, these are called arguments. So 5 and 2 are the arguments. A and B are the parameters. Now, in practice, almost every programmer is guilty of doing this almost all the time. And it's just something that we agree to get wrong, and everybody's kind of fine with it. But in practice, we just use the word arguments for both. It's quite common to hear somebody talk about A and B as being arguments. Most people know that that's technically not true, that A and B are technically parameters, but we'll call them arguments anyways because that's what we often do. So what that means is we can sort of, you'd be understood if you sort of interchange parameters and arguments. There's kind of interchangeable words, but technically parameters are what we refer to the names during definition, and arguments are what we refer to when we invoke the function. We pass it arguments. Okay. Cool. Cool. All right. Let's actually get into the material here. I missed this little note on Slack etiquette. So this is just a quick Slack tip for pasting in code, and it looks like I think most people are doing this already. But if you want to paste in, if you're pasting in code, and especially Python, if I just copy some code like this and just paste it in, it kind of comes through. That doesn't look that great. But if I paste it in formatted like that, it looks kind of more like code. And it's clearer, it's easier to see the indent, it's in a monospace font, and it's sort of surrounded in a way that makes it look more like code. So in order to get that text box, you can do 3 backtick characters like this in Slack. I want everybody to go ahead and try that out and just try to paste in anything, just say hello or something like that. Yeah, yo, something like that. Cool. So backticks, yeah, no worries. So backticks are different than, my bad on this. Backticks are different than single tick quotes or the apostrophe character. So the backtick character on most keyboards, on every keyboard I've seen, is to the left of the 1 key, below the escape key, above the tab key. So your left pinky will get it. Ah, there you go. All right. Yep. And as you'll know you get it right because you'll do the 3 backticks, and then you'll get this like gray, or this this window to type in that kind of looks like an editor. This grayed out window. 3 backticks. Yeah. It'll take a little getting used to. I think most people are getting it. Because it was too tired. I don't get it. Cool. All right. Anytime you're pasting in code, do please send it to me formatted. If you send me a direct message and you want help with your code and you send me unformatted code, I'm not even going to try to read it because it's likely that it's not going to be accurate to what your code actually is. So, it's fine if you do that. I'm not going to be like irate if you make that mistake, but my response will be like, "Hey, I'm happy to help you. Would you please use the triple backticks, or there's another way to format code in Slack as well, but just would you please send me a formatted version so I can look at it quickly and accurately." So it's much quicker and easier for both of us if you use the triple backticks. There we go. Cool. All right, we're at about halfway. So why don't we take a short break? And we can reconvene at, let's see, what would that be? Let's reconvene at 4 after the coming hour. There we go. Here it is. There we go. All right. So we got a breakout here. This is just a 2-minute breakout. I apologize because this was a concept, the thing being driven at here was a concept that I actually didn't talk about. It does cover it in Learn. I will talk about it afterwards though, but for those of you who might have encountered that concept in Learn, we'll just give this breakout 2 minutes real quick. Let me just find it. Okay, cool. Go ahead and get in your best answers. This is the just a snippet from the solution. We'll talk about that second one there. I know people basically don't know what's going on with that, and that's okay. So the 4 scalar types that we talked about, that we discussed briefly, I saw some people put none in there. That's not incorrect. This says string, but none technically is a scalar type. But string is also a scalar type. So we have integers, floating point numbers, booleans are numeric types. We have string, and we did briefly mention none as well. What is 1 over 100 to the, and this is what, 100,000th? 100,000, yeah, 1 to the over 100 to the 100,000th. Give us and why. It gives us a 0 because the value is too small to represent with a float. So there's this thing called an underflow error. And let's just take a look at this. If I make a float 0.01, I'll do this. We'll just keep adding some. Okay, so let's see what we get. So you can see we kind of start getting the numbers in a different format here. And at some point, fairly soon, next few, we should start getting some unexpected result. Okay. Did my interpreter update to handle this, so now my point that I'm trying to make is no longer relevant? People updating technology to make it better. Okay, well, evidently my interpreter is capable of handling a floating point number with this level of precision. Okay, I wasn't expecting that. It didn't used to, I promise. It used to be broken. Okay. Not sure why that's happening. I've used that example before. Okay. This is this is actually going to give me what I wanted here. So this is causing an underflow error, and oh shoot, you know, I just realized this might be a special case because I'm doing this all zeros. I think I want to do this. I'm going to replace all of these zeros. 1 second here. Let me just get them all selected. Let's do this. 9's like this. And I'll just do 0. Let's try that. Okay. Maybe it handles that one particular case differently. So this is the point that I was trying to make earlier. This is actually demonstrating it. So at some point, you can see our number is unable to be represented accurately, right? Python's just going to move it over to 1. So it's accurate up to, what is this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 decimals of precision. You might look at this and say, oh, okay, so Python just rounds. It'll just make it'll round to the nearest number when the floating point gets too small. And I mean, that's a way of looking at it, but it's not actually doing that on purpose. This is not an intended feature as much. This is a limitation. This is expressing a limitation of your hardware, essentially, or of my hardware here. So yeah, this is an underflow, called an underflow, when the number gets so precise that the machine is just literally unable to represent a number that precise. In a greater sense, there are ways around that limitation. There are like big floats and bigger floats and things like that in other languages, but the default float built into Python is limited in that regard. Cool. Okay. We got another breakout. Let's do this one. Nope. Okay, we'll wait for the zoom tools to get on my way. Okay, cool. There you go. Okay, here we go. Let me see. Let me see here really quick. High five, high five. Yeah, okay. We'll just skip through that for now. Using print to output to the console. So I think this is essentially an established concept at this point, but we're going to cover it anyways because it's important. So print, I want to establish this idea. Print's job is to make whatever you pass as its argument visible on the console. So if you pass an expression, that expression will evaluate, it'll crunch down into its expressed form until it expresses whatever value it's going to give back. It expresses that value, and then that value is then the argument to print, and then print writes that to the console. Print takes any number of arguments, so it can take 0 arguments or, I don't know, 1,000,000, whatever. You can take any number of arguments. And then, yeah, we had a question about this, I think, day 1, about what's the difference between print and return, and I said we would come back around to that, and this is it. This is the moment. We're coming back around to that. So this is a common question. It's something that that a lot of people can get confused on. So let's just take our subtract function, because it's a nice simple function. There's not much going on here, right? So one thing that I'll see people do, they'll look at the way I do things, or they'll look at some way of doing things, and they'll say, oh well, I want to develop my own style, so maybe I'll do this a little differently. Maybe instead of returning, I'll print, and then that way I don't have to print here. So you might look at these and think this is like a stylistic choice, that these are equivalent ideas. And then you run your code, and great. Looks like they're the same, right? We got a question about the last breakout, and I'll address that in a second here. So these look like they're the same, but I want you to remember, what return is doing is it's acting on the function and saying, hey, once you're done running this code, make this your output. This is your output. This is what you evaluate to, right? So subtract evaluates to difference. Difference is whatever a minus b was, right? So subtract evaluates to, it literally expresses the value a minus b, right? And it sure looks like that's what's happening in the second definition of subtract here. But if let's do this. If let's say if I add, so 5 minus 2 is 3. If I add 3 to that, I'm going to get 6, right? Well, let's see. If I add 3 to this, I should also get 6, right? And then I get an error, right? So the difference here is not trivial. It's not a stylistic difference. There's a reason I structure things in this way with a return, and then I print the invocation. I'll always print the invocation rather than doing your calculation and then printing at the end of your calculation. So print the invocation itself. You might say, okay, why isn't this one working? Why is one working and the other one isn't working? So let's print this. We're going to get the same error. This says type error, unsupported operands for none type and int, right? So like I said about inputs, your function doesn't actually require input. Well, a given function might, right? Like depends on the function you're writing, but Python doesn't require that all functions have inputs. It also doesn't require that all functions have a return. If you don't specify a return value for your function will return the value none. And I want to be clear here. When I say it will return none, I don't mean that it won't return anything. It will return the value none, the none data type. Right? So if I print this off, I'll take that plus 6 away, I get none. Right? And that's because this, we'll just mark this. So mark none. So this function returns none, so it doesn't actually evaluate to anything. It does the process and prints it off, but it doesn't actually give me the number back. I've just lost that number. Other than just being able to see it on the console, it's out of my program. It's gone. So it's important to have the difference clear in your mind between returning something and printing something, right? Print makes the thing passed to it visible to the console. Return gives a function of value. That's all it does. It gives a function of value. So functions can be thought of as ways to create repeatable procedures. We kind of went through all this. Okay, cool. Let me take a second to address this. There's some questions about the previous breakout. So somebody's saying, where was it? I saw this question. I hope it didn't get deleted. Okay. Okay, good. Looks like we're good to go then. So basic function structure, just to review this, we have our def keyword, the name that we get to choose to name this whatever you want for the function, and then the name of, see, you can even see here, they're calling this an argument, which is technically incorrect, although, again, this is one of those things that we will call parameters and arguments. I've never heard anybody really call an argument a parameter, but just we'll kind of use arguments to refer to everything, parameters and arguments both. So this is the name of the argument, parameter, and then we just return whatever we're going to return, and do whatever process we're going to do in the middle, and use our argument somewhere in there. All right, function parameters. Function inputs that are inside the parentheses of the function header. Operates similar to variables, but they only exist within the function. This is a good point, and it's something I forgot to mention here. We'll take our subtract function, a nice simple subtract function again. So if I do this, and then let's say I try to print A, what's going to happen? It's not defined. Yeah, exactly. Yep. So in this case, we're actually going to get an error. It'll say name error, A is not defined. Right? And you might look, well, I defined it up here, and I called the function. Maybe it needs to come after I call the function. But A just doesn't exist. It's scoped to the function. It only lives within the function there. So we would say that it is local to the function, or it's in the local scope of the function. Pass in arguments to the parameters when the function is called. Let's go through, trying to find something good in here. Just in case it wasn't clear, print and return are different. Default arguments. So this is something that's not going to come up too often. I didn't really start using default arguments until I was much more comfortable with programming. But one thing that we can do, let's say I could set a default value for this parameter b, right? And what that would allow me to do is pass in one value for a. Gosh, I forgot to mention this, but and it's probably clear, right? But when I define the subtract function, I define the parameter a and then the parameter b, and then I subtract a and b. If I change the order of these, we'll get a different result, right? 2 and 5. We'll get -3. And that's because the first argument gets plugged in to the first parameter. So Python knows which value to give to which identifier, which argument to give to which parameter, based on its position, right? So first argument, first parameter. Second argument, second parameter. So these are called positional arguments. So, and most functions are written with positional arguments. That's sort of just the default, right? So first argument, first parameter. Second argument, second parameter, right? We can have a default argument like this, let's say 1 like this, and then we can just pass in 1 argument. So let's say I wanted to do 5, and this will just decrement 5 by 1, right? So this will just give me 4. And if I did 7, this will just give me 1 less than whatever the argument is, 6, right? So this would let me use subtract with one number, and I know if I just pass in one number, it's just going to automatically subtract 1 from it. If I didn't do this, if I didn't set a default like this, and I tried to call this with one argument, notice I'm going to get an error. Oops. So this says type error, subtract is missing one required positional argument. So when you define a function that takes 2 arguments, it doesn't take 2 arguments optionally unless you give it a default parameter, right? Unless you default the arguments. So if you define a function with 2 parameters, you have to supply 2 arguments. There has to be a corresponding argument for each parameter, right? So if I wanted to do this and I expected the behavior for it to decrement its input by 1, I would have to set b equal to 1 like this. So I would have to give it the argument, or give it a default argument there. And basically a default means if I didn't give another value, I gave it a value to assume. So since I'm not giving a value for b, it's going to assume, well, since I don't see a value for b, I'll just use the default. I'll just use 1, right? So I can still use a value for b. I can still do 7 minus 3, and I'll get 4. 7 minus 10, I'll get negative 3. So I can still use it in the same way I normally would. I just have that option to leave that off. Now you don't need to use defaults a whole lot. They don't come in handy, honestly, that much. But it's more like you might see this. You might see functions with default arguments in them if you're going, out somewhere, on the internet and reading other people's code. You might see default arguments. So if you see that, now you know what's going on there. Okay. What happens if you pass in only one argument to subtract? I just demonstrated that. So if I didn't default something and I pass in one argument to subtract, I get an error. I get this error, type error. Subtract is missing one argument. If I default it like this, then I can pass in 1 and it'll be okay. There are some variations on this. I was going to skip this, but I think it's better that I cover this actually. So there's something kind of funny. I can have a non-default, I can mix non-default arguments and default arguments, but I have to do it in a certain order. So if I tried to default A to, I don't know, what would I default it to, 10? This is actually going to give me an error, even if I say 7 minus 3 or something. Oops, 7. So this is its own special syntax error. Dang it, come on. This is its own special little syntax error. So it says non-default argument follows default argument. So we can't actually do it in this order. And the reason for that is the utility of having a default argument is that you can pass less arguments than it actually takes, or you could pass, the total amount of arguments that it actually takes and still override them. So it gives you the option to pass different amounts of arguments. What which parameter should 7 be assigned to, right? And you might say, well, the clear answer is B, because 10 or A already has a value of 10, right? And that's a good enough argument, but I could also say, well, it should go, since it's the first argument being passed, it really should go to the first parameter. But you might say, but this is kind of an exception to that. And it's conceivable that Python could have been written that, okay, so A is defaulted and it's the first argument, so we only have one argument, so we'll give it to the one that doesn't have an argument. We'll give it to the parameter that doesn't have an argument, a value associated with it. That's conceivable, but what about if I do this? If I do something like this? And now I'm really changing the terms of this function. It's no longer a really good subtract function, but imagine I had something where I have 3 arguments and I have defaults and non-defaults kind of mixed in with each other like this. So 7 goes to A, and then 3, which one does this go to? Or something like this. It gets confusing answering that question of which argument goes to what parameter. Gets really complicated really quickly. Even once you start getting into 3 or more parameters, the possibilities just get really confusing. So in order to avoid that confusion in certain impossible situations and certain really weird code, the way around it is to just say, okay, you can have non-defaulted arguments and you can have defaulted arguments, and you can mix them together, but you have to do it in a certain order. That way, when you invoke the function, it's clear. There's a simple and expected rational behavior for this function to have, right? So that's the reason for that. There's also something that we can do in here. I could say, so when I do, A or B equals something up in here, up in the parameters, we call that a default argument. We can do something similar here. I could say B equals 3 and A equals 7. And this will subtract 3 from 7. Oops. So this will subtract 3 from 7 like that. And so these are called keyword arguments, not default arguments. And the reason is, remember how I talked about positional arguments? Right? Positional arguments, find their parameters by their position. Keyword arguments find their parameters by keyword. And this will let me assign them out of order if I wanted to. This is kind of nice, though, because it means that all of your arguments are explicit, right? It's clear which value is going to which parameter during invocation. I don't know that there's really a good reason to put them out of order like that. We could do it in order, B equals 7 like that. So, but yeah, it's a different. even though it kind of looks similar, it's a bit of a different behavior for a different reason, right? So here we have no defaults, but we can still pass these values by keyword if we wanted to. It's just another option. I would say, though, don't worry about that. Don't worry about doing parameter equals a value during invocation. Just, you can ignore that for now. This isn't going to come up or be important for a while yet, you know, so it's a bit out of the scope. Cool. So we haven't really talked about strings. I know I've mentioned strings. So let's see. Strings are the data type for dealing with text. Right, so I mentioned these just kind of briefly, but strings, we can deal with textual characters with the string data type. So the way we make a string is we use quote marks. The Pythonically correct thing to do is to use single tick quote marks like this. I prefer to use double tick quote marks. The single tick quote is the same character as an apostrophe, such as in that's. So if I use single tick quotes to delimit my string, it'll conflict with that character. So for that reason, since I find myself using apostrophes not infrequently, I prefer to use double tick quotes because they don't conflict with an apostrophe character. That being said, you can do what you want. If you have a string that's delimited with single tick quotes like this and you want to use an apostrophe, you can put a backslash in front of the apostrophe, and that will, the backslash is called the escape character, and that will escape the next character that comes immediately after it. And basically it's telling Python, saying, hey, inside of this string, this next character, it's not what you think it is. Don't treat it in the same way that you would normally treat it. In this particular case, it would normally see that apostrophe and think it's a single tick quote to delimit the end of the string, and it would say, okay, the string is over there. But in this case, backslash apostrophe means no, it's not a string delimiter, it's literally an apostrophe character. If you're wondering, and I'm sure some of you might be wondering, how do I put in a backslash character? It's backslash. That'll put in a single backslash. So let's print text here. That's. So anyways, I kind of like to avoid that confusion, and I prefer to use double tick quotes. That's my reasoning. Most people still use single tick quotes. That is the Pythonic thing to do, is use single tick quotes and then backslashes in front of apostrophes. But I like double ticks. So yeah, you can just write whatever you want in a string. And then you can print it out. We can do some cool things with strings. So we can add strings together with the plus operator. And when we talk about adding strings together, we say we're concatenating them. So I could add hello and Clark to each other, and I get the string hello Clark. Notice there's no space into it in there, so let's put a space in there. So I'll put a string with a space in it like this, and then I'll add it right in the middle there. So I'll concatenate these three strings together in this order. And I'll say this. I can also I can also multiply a string by an integer, right? And I'll get a I'll get that string repeated as many times as I'm multiplying by it, right? So I wanted to do this. I wanted to show you this example. This is kind of funny, right? We have an order of operations issue here. So when I did hello times 3 is hello, hello, hello. And I was like, okay, well, I don't have a space in there. So let me go add a space. So if I say plus space, and then I run this, and I only get one hello, and then I don't see any spaces. I assure you there are 3 spaces being printed out after this, although we can't see them because a space is not a renderable character, right? It's literally empty. So what's happening here is PEMDAS, right? Now, even though that we're not dealing with numbers, multiplication of strings still takes precedence over addition. So PEM multiplication DAS. So in the case of strings, it would just be PMA, I guess, because parentheses multiplication and addition. But it's also not called the addition operator when we use it with strings. It's the concatenation operator. And it's also not called multiplication. It's called the repetition operator. So I guess it would be PRC, parentheses, then repetition, then concatenation. So I can use parentheses here to make sure that text plus space gets evaluated first, and then text plus space gets multiplied by 3, like that, and we have hello, hello, hello with spaces in it. Cool. So that's just some basic string manipulation stuff. This thing about parentheses kind of comes up all the time in the context of math and outside of the context of math as well. So you use a lot of parentheses to like make sure that your code is evaluating in the order that you want it to evaluate in. And the takeaway with this is that we have strings. We delimit them with quote marks, single or double tick quotes. You can pick whichever one you prefer. I made my case for the ones that I prefer, and you can use the plus operator to concatenate strings, and you can use the multiplication operator to repeat strings as well. Okay. So there's a special kind of string called an F string. And F stands for format. And I'm trying to think, like, what would be a good... Yeah, let's just do this. We'll do a name, and we'll say... Jesse, and an age. We'll say Jesse is 27. And let's say I want to print something like some person's name is their age years old. Right? So I can use an F string, and the way I make an F string is I just stick an F in the front of a string, and I can template in certain information using curly brackets like this. Okay, curly brackets. So inside the curly brackets, I can put name and then age, right? So inside the curly brackets, the way that my particular syntax highlighting works, the interior of the curly brackets is highlighted like the rest of the string. I kind of wish it wasn't. There are other syntax highlighters that'll actually kind of fix this issue, but this makes it look like a string, but it's actually sort of escaped out from the string. It's sort of this is an expression that Python can evaluate as Python code. So I could put whatever Python expression I wanted in here, right? So in this case, I'm just putting variable names, which are valid expressions. They express their values, right? So name is an expression that is going to express Jesse, and then age is an expression that's going to express their age. So this says Jesse is 27 years old. If I had a different name, is Joanne is 38 years old. Right? So I could just change these, and this string changes, right? So what's happening here is basically before we run the code, this string is sort of undecided, right? It's not fully developed, right? So when it sees the f string, it's going to go, oh, okay, so I need to resolve the states of whatever's in those curly brackets. And then once that's resolved, Python wraps all that up into a string. It sort of dynamically generates a string for us. There's another way to do this. Which is the dot format method, like this, dot format. And we'll still put in the curly brackets, but we won't put in the expressions into the curly brackets. We'll put them in the arguments of dot format. So we'll say name and age, like that. So the first argument goes into the first set of curly brackets. The second argument goes into the second set of curly brackets, like that. Joanne is 38 years old. Okay. Bonus function. Okay. The input function. So let's talk about the input function. Actually, you know what? Variable scope. We are really close on time. We just got a few more breakouts. I'll do these breakouts at the beginning of class. I'll talk about variable scope really quickly. And we'll get into input tomorrow. Excuse me, no class tomorrow. Next class is Saturday, midday. So real quick, we'll talk about variable scope. So I want to cover this because we already kind of touched on it. When we were talking about A not being available outside of the function, right? So A is in the local scope that is local to this function. One thing that Python lets you do, I honestly wish this would throw an error. I wish it wouldn't let you do this. I'm going to show this to you, and I'm going to tell you, I'm showing this to you because I want you to avoid it, not because I want you to do it. So one thing I see is something like this. You know, people will be writing a function and they'll be like, okay, well, I'm trying to solve this problem. I'm trying to turn it into a function. So I have to have a value for my parameters. So why don't I just do this? I'll say b equals 3 and a equals 10, and then I'll say subtract, and then, you know, and then you might think, oh, well, you know what? I don't even need those weird parameters. I've already got these perfectly good variables that I can use. And then I don't even need to worry about passing it any inputs. But the problem is now we can't pass it inputs. You know, the thing that made this function useful was inputs. Also, this now, this should be called 7 because it takes in, it doesn't take in anything. It uses these variables A and B and subtracts them and then just returns 7. But 7's not really a good name for this because we don't really know what this is going to return. We don't really have control over what this is going to return, because what if these variables change? So we should just call this some unknown number, something like that. We can't really. It's like using this function has now become strange and difficult. So you don't want to use variables from outside of your function in your function. The only way, and you might think, well, how are like if I have variables out here and I want to use them in my function, like how am I going to use them if I can't, if you're telling me I'm not allowed to use them, right? So what you want to do, what I mean by that is you don't want to just use them. You don't want to just use them out of nowhere, right? I don't want to just have a variable x equals 10 up here and then just use x in my function just randomly, right? So I don't want to use, basically what I'm saying is inside of your function, you only want to use your parameters and anything you create inside the function, right? So difference is a variable that's local to this function. If I tried to print it out outside the function, it wouldn't exist. Same with the parameters. Python will let you use variables from the global scope. It'll just let you use functions from the global or variables from the global scope in your functions. The problem is those variables can change, and if those variables change, then the behavior of your function changes, and it probably won't be clear why, right? So you'll go change some value x, and then it'll change how every instance of that function that was dependent on the value of x works from then on, and it'll probably be really confusing, right? So when you're inside your function, you want to make sure that the things that you're using are only variables created inside the function or the parameters. That's it. If you have something from the global scope and you want it in the function, the only legitimate way to give it to the function is as an argument, right? So I can pass x and y as an argument. That's totally fine. These are global variables. I'll just pass them to the function as arguments, and then I'll have my local parameters, my local variable, and then return this. So my process in the function is only using things that are local to the function. So basically that's the rule with local versus global variables. Okay, cool. We will wrap up here. Yeah. I'm going to stop the recording and we can do questions.